Today we're going to start talking about surface area of three-dimensional figures. We'll have some net, which is just basically disassembling the figure, and that will kind of help us in trying to find the surface area. When we think of surface area, think of painting the outside of the object. If I were to paint every part of the object, and don't forget the bases, but that is what the surface area is, everything that's touched by this on the outside of the surface. So the first thing we're going to look at is constructing net figures. And what we're doing with these net figures is we are reassembling the shape that they've come from. One thing you want to pay attention to is the bases. If there are two bases, then our shape is considered a prism. So we have these two shapes right here. So what we have in this case is a prism because we have two bases and this is four sides. If we were to reconstruct this figure, what we would end up with is a cube because all four of these sides are the same, plus the top and the bottom, which means this shape is a cube. A cube could also be called a square prism, but a cube is a better description, which means all six of the sides are the same. So as we take a look at this net, what we're going to do is identify, first of all, it looks like they all have very similar bases, but if I'm looking at this shape here, that looks like it is a base that is a square. All of these do have bases that are squares because we see two sides on either of these. These are all prisms. A has a problem because it only has three sides around the edge, but you can see we have one side on the bottom, two on this edge, three on the top, four on the left edge. So we need something that has four sides. And those four sides, so C is out as well, and those four sides need to match our shape. So let's take a look and see kind of what we have here. The long edge of these shapes are hitting our squares. Here's what I mean by this. This is the long edge of the rectangle, and this is the small edge of the rectangle. Well, on our figure right here, you can see the small edge of the rectangle is running into the square. We need the small edge to run into the other rectangles. We need the large edge to touch the squares, excuse me. So B is not what we're looking for because the large edge of the rectangle is touching more rectangles. So the only answer we have here is D. So as we look at this shape, first of all, we could just count the number of faces. We have 1 and 2 on the top and bottom, and then we have a third one on the front, fourth one on the front, and then the back is fifth. So we only have 5 faces. A has 6, and B has 6 faces. So what we want to take a look at here is which one of these shapes left best represent what we see. So as we look at the remaining 2 shapes, what we want to do is try to take a look at the rectangle that is not at an angle, which would be this. I think we can visually see that this is the larger of the 2 sides of the right triangle. So the larger of the sides of the 2 right triangles is touching the triangle, and the smaller is the rectangles touching each other. So if you look at D, it's the small side of the rectangle that's touching the triangles, and the large side is touching the other rectangles. So when we look at this, C can be our only answer based on that. That one's a little bit confusing, but my suggestion to you is try to find the shape that is not at an angle, because we're more familiar with looking at shapes that are not at an angle. So as we take a look at this one, first of all, we have to name it based on its base. And we only have one base here. and it's a triangle. So we know it's not a rectangle, we know it's not a square. So it's a matter of whether this is a triangular prism or a triangular pyramid. Well, when you have a triangle prism, your lateral faces are always squares or rectangles. These are clearly triangles, which is the lateral faces of a pyramid. So this is a triangular pyramid. Now, actually calculating. It says Eli is decorating the outside of a box in a shape of a square pyramid. The figure below shows the net of the box. What is the surface area of the box in square inches? Well, let's first keep it simple right now. We have one shape, 2, 3, 4, and 5 shapes. Well, 2 through 5 are all similar triangles. So once I find the area of one, I have the area of everything. So let's do the square first of all, because it does tell me that it is a square pyramid. So if this is a square, even though they only gave me one side, if one side is 6.8, they're all 6.8. So we're going to go 6.8 squared, and we learn that our area of our square is 46.24. So we're going to now find the area of the 4 triangles. Well, the triangle, let's highlight it a little bit here. We'll do this one in green. Shape 2. Reason why I'm doing 2 is because it's actually labeled. Is a triangle, first of all. So the formula is 1/2 base times height. Well, the base of this triangle is 6.8 because the base of this triangle is the side of the square. So if this side is 6.8, the opposite side is 6.8. And then the height of our figure is 5.4. So what we end up finding is the area of this triangle is 18.36. But our surface area is the base plus the 4 triangle areas. So our base was 46.24 plus 4 of those triangles, which were 18.36, which is 73.44, plus our base of 46.24, gives us a total surface area of 119.68 square inches. So this is how we find the surface area of our shape. There's a formula for this as well. If you do base area, plus 1/2 times the height times the perimeter. But I feel like this formula is just going to be more of a confusion. Whereas if we can just break down the net, we can do this on every type shape. So this question's a little bit trickier. It's given us a net with the area inside, the surface area of each one. Find the values of the possible dimensions of our rectangular prism. So we're going to have a rectangular prism. They told us so. So it's going to look like this. And there are 3 dimensions. We need the length, the width, and then the height. Depends on how you look at it. Doesn't matter because it's a 3-way multiplication. So let's take a look and see what we have. So as we look at these answers, some of these are going to just immediately be discounted. Because we can't multiply times 32 and get a 12. So this answer's out. And although 2 and 8 go into all of these numbers that we see over here, 9 does not. So since 9 is not a factor of any of those numbers, because we need it to be a factor of all of those numbers, since 9 is not a factor of any of those numbers, then it cannot be a correct answer. So we either have a 2 by 6 by 12, or we have a 3 by 4 by 8. Well, let's just plug in our numbers and see what we have. So if we were to, let's do the 2 by 6. Let's say the entire figure was 6. 6 in our width here. That would mean that's 6, that's 6. Well, that would mean this is 12, leaving us with this being a 2. Well, 6 by 2 is not 24, it's 12. So we know this area is going to be wrong on our shape here. We have one other dimension here. No, we had that right. That's what we have. All right, so let's try the next answer and see if it works a little better for us. So our dimensions would be, could be, it's 3 by 4 by 8. Well, let's do the 12. Well, if this was a 3 by 4 by 8, this is clearly the smaller of the two sides, so that would be the 3, that would be the 4. And that would leave this to be the 8. Well, if we were to fold these edges back, what we would see is since we fold the 4 back, it immediately touches the 32. So this side would be 4. We fold the 8, you could see if you try to envision this, and by the way, this would be 4 as well, this would be 4. So we need to decide what this side is. Well, if we were to fold this down, this would be the bottom of our figure right here, with the edge 8 touching this edge up here of 8. So what we see is all of these values do work, because this square that we first look at would be 8 by 3, which is an area of 24. So would this. And this is 4 by 3, which is an area of 12, which this opposite face is as well. And then the last thing is 8 by 4 is 32 square centimeters, which means this is also 32 square centimeters. So that would be our answer, the sides of 3, 4, and 8. So in this example, what we're going to do is establish what we do know, which is this. We know that this triangle right here has an area of 16, and it has a side missing or unmarked. Well, if the area is 16 and the side is over here is 8, that means this missing side has to be 2. So as we keep looking, we also know this is 3, so we know this is 3, we know this is 3, right down the line. So what we need to do is to establish, well, what is this side right here? Well, as we try to fold this shape back up, what you need to recognize is when we fold this back up, this edge right here will come in contact with this edge right here. So they'll be sitting that way. And this edge right here will be the front bottom edge of the base, which will end up touching this side right here. So if this is 2, this is 2. So let's go back to our questions here. What is the area of the edge, excuse me, what is the area of the edge that's missing? That would be the A value. Well, that would be 3 by 2, which is 6. And then what is the length of the missing edge? That would be 2. The answers are kind of asked in a backwards order, but that's fine. Solid is cut by a plane. It says a solid is cut by a plane that is perpendicular to the base. It means a right angle from the base. Forming a two-dimensional cross-section in the shape of a triangle, which of the following solids could this shape have been? Well, let's think about what we have here. If I had a cube, looks like this. Think about like the game Fruit Ninja that was a thing. If I were to take a sword and slice this right down the middle, grab either side, the shape I would be looking at on either side would be a square after cutting these in half. So that's not what I have. If I have a sphere, spheres are hard to draw. Spheres are a ball. But if you were to slice a ball in half, the shape you would be looking at is 2 circles. So that's not what we're looking at. Here's the one that we often mistaken. A triangular prism. It actually says a right triangular prism. So here's a right triangle. A right triangular prism is going to look like this. Just like that. Almost like a block of cheese on this thing. So think about the block of cheese. If I were to take this block of cheese, if you've ever done this, got a prism here, and I were to slice it right down the middle, what face shape would this be? Well, think about what this would be. It would be a rectangle. It would be a rectangle. Because you have 1, 2, 3, 4 edges. 1, 2, 3, 4 means that it's going to have a rectangular cross section. And a triangular pyramid, I actually have a picture of this one, is going to look like this. When we cut this figure in half, and the thing that made it a triangle is not actually the triangle, because you could see it didn't work in this one. It's the fact that it was a pyramid. Pyramids are going to have cross sections that are triangles. All right, the last thing, we're not going to spend a whole lot of time on formulas. We're going to talk about just practical solving here. So first thing we need to recognize is what we have. We have a rectangular prism. Well, a rectangular prism has 2 bases, top and bottom. And its lateral faces are rectangles, which is base times height. And we have 4 of them. So let's do this. Let's find the area of the base. The bases, there's a base on the bottom, and there's a base on the top. So this is what our shape looks like from a 3-dimensional look. So the area of the base that we see, well, it's 4 by 3. So the area of a 4 by 3 is 12. Well, the top would also have an area of 12. So we have 2 bases of 12. Now as we look at the rest of these, we don't have a cube here. So we don't have around the edge 4 equal sides. The opposite sides are equal to one another, but so this side right here, we'll call it 1 and 2 are equal to each other, but side 3, which is the front green one, and the back are equal to one another as well. So we need to find the area of each of these pieces. So I'm not using the correct formula. I was using a cubic formula, which is not correct. Let's find the area of these different sides. Well, the red face is 4 by 3, so it has an area of 12. So this side right here has an area of 12, which means this side right here also has an area of 12. So we are going to add another 24 square yards to this amount. Now the face in the front. Well, let's erase some of this stuff so we can maybe more clearly see what we're doing. Our shape in the front here. Well, if this side here is 4, this side here is 4, and so is this one. So this green square that we're looking at the front is 4 by 4, which is an area of 16, and we also have an area in the back, which is 16. 16 and 16 make 32. So we have this. 48 plus 32 is 80 square yards. And the last one we have here is a square pyramid. So we have one base in this, because prisms have 2. This one only has 1. And we have 4 sides, which are triangles. And all 4 of those triangles are equal to one another. So all I need to do is find the area of one of these triangles. Let's do the area of the square first of all. The bottom square is 6 by 6. That's 36. Now, if we were to take this triangle apart right over here, it has a base of 6 and a height of 7. The formula for a triangle, of course, is 1/2 base times height. Half of 6 is 3. 3 times 7 is 21. So the area of one of these triangles is 21 miles. So we are going to multiply that times 4 because we do have 4 sides. So we have 36 plus 84. This is 120 square miles. So I'm going to give you a shape that has formulas on it, a sheet, excuse me, that has formulas on it. You're welcome to use those formulas, but more importantly, we need to be able to reason together what these shapes actually are. It's called a net, but let's break it down into what these shapes are actually looking at. Like here we have a square and 4 congruent triangles. So we just find the area of each, add them together. You guys have a delta math attached to this. Good luck.